Welcome back. Today we're going to talk about equations, solving equations with variables on both sides. So we're beginning a new module where we're going to be solving equations and systems of equations. So the first thing I want to do with you is a quick review of solving equations with variables on both sides. So these are equations that, like the definition says, has variable terms with variables on both sides of the equation. So when you have these terms, remember you can't combine this 20x with the 11x. It's not, if they were on the same side of the equation, we could combine them by adding or subtracting their coefficients. But here that's not the case. We have 11x on one side and 20x on the other side. So what we want to do is we're trying to get all the terms with variables on one side and all the constants on the other side. And that way I can just divide by the coefficient of the variable to get rid of that and isolate the variable. So here, there's two moves I can make. I can either subtract 20x from both sides, right here, or I could, subtracting because this is a positive 20x, or I could subtract 11x from both sides. Now, if I subtract the 20x from both sides, which is totally fine, I'd get a negative 9x here, which is fine, again. If I subtracted 11x from both sides, I get a positive 9x on the left side. So what I'm going to do is, I always like to try to keep my numbers positive, so I like to take the smaller amount of x's and subtract them from both sides. It's just more strategic that way. Okay. Now, when you do this here, it cancels out the 11x, and really what you have to be careful of is this right here can be read as a negative 31. And that's sort of a shortcut because I can't actually leave a subtrahend without a minuend. So what I would have to actually do is turn it into, use KCC and turn this into addition and make this a negative 31. So what's left on the right-hand side is a negative 31. Okay. Now, in 8th grade, I don't need you to show that, I don't need you to show the KCC process that leaves you with a negative 31 on the right-hand side, but I do need you to understand that that's actually what's going on here. That I actually, in my mind, I turn this into addition of a, of the opposite, which was negative. And so that left a negative 31 here. Okay, right here we would get 9x, okay, minus 4. So notice that the right-hand side, I have no more terms with x in it. And the left-hand side, I've sort of pulled all of my terms with x's on the left-hand side. Okay. And again, it doesn't matter if you take it on the left-hand side or the right-hand side, as long as you're trying to get all the terms with the x on it on one side, whether it's left or right, and all the constants on the other side. Okay. So here, I want to get I want to get the constant of 4 on the other side. So since this is being subtracted, I'm going to use the inverse operation and add 4 to it. Right here. And I have 9x is equal to negative 27. Okay? And now I'm going to divide. And so at this stage, notice that I've achieved what I've wanted to achieve, which is I get all the terms with the x on one side and all the constants, those are the numbers without the variables, on the other side. Okay? And now I can just divide through by the coefficient of x to get x is equal to negative 3. So I've solved this equation right here. And I can always check and put this back in here for x and here for x. So we'd have 20 is times negative 3 minus 4 is equal to 11 times negative 3 minus 31. Okay, this would be negative 60 minus 4 should be equal to negative 33 minus 31. Okay, that's negative 64 is equal to negative 64. Okay, so I've checked it. Remember, with equations, you can always tell if your answer is right because you substitute the value back into for the x and make sure the left-hand side is equal to the right-hand side. All right, let's do one more example here. So here, again, I have variables on both sides of the equation here. And what I'm going to do is, strategically, I'm trying to get a positive coefficient for x, so I'm actually going to add 13x from both sides. Again, I'm adding 13x because I want to get a 0 amount of x's on this side. And since positive 13 is the opposite of negative 13, that's why I chose that. So I'm going to add 13x to both sides. This gets me a 0, so those cancel. I just have 77 left on the right-hand side. And here I have 9x. Okay. Plus 14. Now I want to subtract 14x oh sorry, just 14 from both sides. I have 9x is equal to, that's 3, and that's 63. And again, I divide by 9 from both sides, and I have x is equal to 7. And I could check this by putting it back into the equation, but I won't. I'll save time here by not doing that. But that's essentially what you learned in 7th grade about how to solve equations with variables on both sides. In 8th grade, we're going to bring in the word problems, okay? So let's say Andy's car rental charges an initial fee of $20 plus an additional $30 per day to rent a car. So Andy's fee is $20 plus $30 per day, okay? And Buddy's car rental charges an initial fee of $36, so Buddy's, this is 20, 36 plus an additional $28 per day. Now the question is, for what number of days is the total cost charged by the company the same? Now, what we're trying to figure out is when these two equations are equal to each other. So this leads us to actually, because we're wondering what amount of day, for what amount of D here, or days, do the charges, so both of these equations represent the charges. So for what number of days the total cost charged by the company is the same. So what we're going to do is actually, the trick is to set them equal to each other. To take Andy's cost and set it equal to Buddy's cost. And we're asking ourselves, whoops, should be 28. We're asking ourselves, for what D value does this happen? Okay. So here, notice I've just taken the Andy's cost and set it equal to Buddy's cost, and this leads us to the type of equation that we just talked about, right, where we have variables on both sides. So let's go ahead and start solving these. I picked 28 because that leaves me a positive 2 on the left-hand side here. Okay. We've been getting variables on the left-hand side, but we could very easily get the terms of the variables on the right-hand side. That's totally fine too. Just happens to be this case for some reason right now. So I have 2D is equal to 16, and divided by 2, D is equal to 8. So after 8 days, the charges are the same. And let's check this out. After 8 days, we'd have 20 plus 30 times 8. Well, 30 times 8 is, that's 3 times 8 with an extra 0, so it's 240. And 20 would make it 260. So at 8 days, the charge would be 260. Here would be 36 plus 28 times 8. Well, 28 times 8 here is, whoops, that's 64 right here, and 16 makes it 22. So it would be 224 plus 36. Let's just go ahead and add those on top here. And that would also get me 260. So the answer here is, at 8 days, both Andy's charge and Buddy's charge is $260. So notice what I did was I made a cost structure for both Andy and Buddy, and then I set the cost structures equal to each other. And then asked myself, for what D value does this work? And then I checked my answer by figuring out if I put that amount of days into both cost structures, do they indeed get you an equation like that? Okay, so if we had to come up with a real world situation that could be modeled with the equation 50 plus 25x is 55x, what we could do is we could think about what just occurred in the last slide. So these are two rental charges, two companies' rental charges, and we might be wondering for what day are they equal to each other. So we could think about these as being cost structures for some companies, right? So it's possible, maybe this is a cleaning service, right? So maybe the cleaning service charges an initial fee of $150 to arrive at the house, and then $25 per hour after that. Whereas another cleaning service doesn't have an initial fee, but it has a higher per hour fee. And we might be wondering, for what value of the hours do these two things equal each other? So in order to come up with a real world situation, you really want to think in terms of situations like we did before, where we have an initial fee plus a per day or per hour or per minute fee. And then another cost structure that doesn't have an initial fee but has a per hour fee, or any other situation where it doesn't have to necessarily be cost that we're looking at here. It could be anything else that we have used to model linear equations with. But in terms of looking at modeling equations with variables on both sides, we want to think about reasons why we'd want to set them equal to each other, like we just saw with the rental charges. Okay? Okay, this is another situation where you might be given a verbal description of these two equations and asked to find the number for which they're speaking of in the situation here. So this is the first time we've seen equations like this. So, well, you might have seen this in 7th grade, but I want to go through how to go from a verbal description of an equation to an actually algebraic description of an equation. So, first of all, this is an equation because this word right here is the same as. That's your equal to sign. Okay, so everything that came before it is going to be on the left-hand side of the equation, and everything that comes after it is going to be on the right-hand side. Okay, so the product of a number and 10 decreased by 3. Well, the product of a number, so the number is what, this is your x, right? Okay, now we're sort of work backwards in this statement. The product of a number and 10. So the product of what? Okay, a number and 10. So 10 times x, because we don't know what the number is. Now this product is decreased by 3. Okay, so that's how you translate that top part into an algebraic expression. Now we know this is the same as, or equal to, the difference of the product of 4 and a number. So with differences, you have to be careful because they always say the word difference first, and then you have to, all the words after it describe both the minuend and the subtrahend. So the difference of what? So we know that there's going to be two things, and we're going to be subtracting them. Okay, what are the two things that we're subtracting? Well, the first thing that comes about is the minuend. The difference of the product of 4 and a number. So actually, let me put that in. The product of 4 and a number. So that's the minuend right here, or the first part of a subtraction problem. The product of 4 and numbers, that's 4x. Okay. Now, it's the same number that was described in the first part of the equation here. So I can use x to as the variable to represent that number. Okay, the difference of the product of 4 and a number and 45. And separates the minuend from the subtrahend. So here, I'm going to write this as 45. So the equation that I'm led to is this equation right here. Oops. Okay, and then I would just use all my strategies in order to solve this equation right here. But what's most important is that you understand how to translate this sort of description into an algebraic equation. Okay, so here I'm going to choose to subtract 4x. We have 6x minus 3. And again, we see that our term is on the left-hand side. For some reason, it seems strange. They're always coming, the x term is always on the left-hand side. But remember, it doesn't have to be that way. So 6x is equal to negative 42, divide by 6 here, and we get x is equal to negative 7. Okay, if we put that back into the equation, we'd have negative 70 minus 3 should be equal to negative 28 minus 45. So 28, let's see, plus 45 would get you that negative 73 right here, and the left-hand side is also negative 73. Okay, so I've checked my equation. My answer is negative 7. All right, and that's the end of the lesson for today.